Yo, what's up, calculus students? We're gonna learn some stuff here about the accumulation function. What does it mean to be an accumulation function? It means it's an accumulation where we have a variable as one of the boundaries. Some confusions that occur is like, what the heck is going on with x's and t's? Why do we have two different variables? Well, the whole thing actually isn't accumulation unless it's like you change x and you accumulate g, where like g is just given to you. It has to be like this. What I try to tell students is if you just ignore this, it's probably easier to understand and like know that you don't have to worry about t's. You're just worrying about x's. And what's great is we're back in x and y land. So like all the t's and positions and stuff like that, it's gone. We're back in x's and y's. And the key is understanding what we have. This is the graph of G on the left. Okay, that's the graph of G. And we talked about / discovered in class that the derivative of F equals G. Why is that true? Because accumulations and antiderivatives go hand in hand. I can't spell, but you get it. Which means like if you want an accumulation, you could take an antiderivative. If you want an antiderivative, you could actually look at an accumulation. And the way we kind of like understand that the derivative of this accumulation nets out, cancels each other out, is at the last page. I kind of want to get into this last page first, where it's like, hey, write an expression. Now, this is something that is not very important for your test coming up, but it'll be seen on multiple choice. And what I'm saying is like, hey, you don't have a calculator. If I asked you to evaluate this integral, since you don't have a calculator and you don't have a graph, you need to take an antiderivative. So you take an antiderivative of sine t, you get cos t plus c. And this is the whole purpose of like, I need t's. Because I then am going to plug in x, and then I'm going to plug in 0. When I subtract, the c's will go away. I get negative cos x. This is 1, negative 1. This is plus a negative 1, which is plus 1. Okay, so like, what did I just do here? I just took the antiderivative. It's like if I asked you to accumulate x squared, and you don't have a calculator, you have to use the antiderivative. 1/3 x cubed plus c, you plug in 2, you plug in 0, you subtract, you get 8/3 minus 0. The c's will go away. Okay, so let's even skip the third one. Let's just go and do the first two. If I were to evaluate this, and again, I'm not going to get a number because I have x here. You'd get t squared plus c. You would plug in x and 1. Last unit, we would plug this into kind of like our sign analysis to understand how you would subtract the positions to get the accumulation. But here we're just going to, use this line to say find the change of this between x and 1. Now, why do I do this? And that's to show you that if you take the derivative of an accumulation, if you take the derivative of an integral, it's just going to go away. We see that an expression for sine t from 0 to x accumulated is this. If I take the derivative of this, what happens? And this is a big important point about like what happens to this 0 and what happens to this 1? Well, the derivative of negative cos x is positive sine x. The derivative of 1 is 0. The derivative of this integral is just the function on the inside with one difference. Like the variable becomes x instead of t. It's like if we ignore the dt and really just like worried about sine t or like f of t, it would just turn into f of x. So here you could see the derivative of the accumulation is just 2x. Gosh, change this. what's the derivative from 1 to 2 to t, 1 to x of 2t. And it's like, well, I wrote an expression. It was x squared minus 1. This is me taking an antiderivative. You take a derivative of an antiderivative, like the integral is going to go away. It's replacing the t's with x's. It should make sense. It's kind of complicated to look at this. Don't worry about, I don't get this last page. It's like, it's really not a big deal for now. As long as you understand if you take a derivative of an accumulation, because accumulations and antiderivatives go hand in hand, it's like a derivative of an antiderivative, things go away. All right, cool. Now that we got settled, we understand that this graph, the graph of g, is actually the graph of a derivative. It's the graph of the derivative of f. F prime equals g. Okay? So keep that in mind. We're going to use it later. Starting with finding some values, all you got to do is look at some accumulations, some key things to remember. Above the x-axis, below the x-axis, positives or negatives. Add up all of the area from the x-axis above or below. If I'm going from 0 to 6, I'm going to need this positive area here. This is a triangle. We can use geometry to find the accumulation. It makes sense. I hope you watched the lesson video if you weren't here. And then 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is a 1/2 5 times -4. Again, you're using all of this area, and you will use a negative height. These are negative g values. Accumulating these negative g values, you're going to get this negative area of 10. Don't just count up the boxes. It's going to take too long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I guess, you know. So cool. F of -4, if I went backwards, this is important. Going backwards is the opposite of going forwards. This is familiar to us from our idea of if I have a derivative, and if it's positive, and if I know, say, f of 2 is 5, and I'm asking you for f of 0, and you know that the accumulation of your derivative is positive 8. What do you have to do if you accumulate your derivative from 0 to 2 and you get positive 8? You have to subtract it if you go backwards. So 0 to -4, I'm immediately saying take the opposite of -4 to 0. Okay? So backwards, subtract. Now what I want you to do, though, is find the area from left to right. Add them up. Take the opposite of your answer. So here I'm going to split this into a triangle, base 1, 2, height 1, 2, 3, 4, 5, 6. So this is 6. This I'm going to split into a rectangle. This rectangle is 8, base 2, height 4. And then this triangle up here is a base 2, height 2. So this is a 2. So -4 to 0 would be 6 plus 10, which is 16. Take the opposite of it, you get -16. Now hold on to these values. I asked you to find them for a reason. Now, what is f prime's value? F prime's value, well, here's like making sure you have established the connection. What's important, especially for the next lesson, is don't just do this. Oh, I'm supposed to just do this when asked to find the derivative. I know that the derivative of f is g, so I know f prime is equal to g. G of 4, this is the graph of g, of 4. That's y value. It's the y value of g. If I ask you for f double prime, well, look, take another derivative, and you get g prime equals f double prime. F double prime equaling g prime, that means the slope of g at 4. Go to 4, What's the slope? Rise over run, rise over run. 1 over 1, which is 1. Cool. Now, two different sign analysis we could do so that we understand F and what's going on with F. One sign analysis would be of F prime. Well, F prime equals G. Another sign analysis can be of F double prime. Well, F double prime equals G prime. Now, let's do the one on the left because it's actually easier. We know when F is concave up, I'm going to go ahead and just like get my sign analysis set up so I know what I'm looking for. When F is concave up, F prime will be going up. F double prime will be positive. You could start with that. And then you add in your connections. Okay, F prime is G. F double prime is G prime. That means F is the antiderivative of G? Sure. Who cares? Let's see. I am looking for when G is increasing or when G's slopes are positive. When is G, this is the graph of G, going up? When is its slopes positive? -4 to -2, 2 to 6. Cool. Now, finding max values, we have to do our sign analysis. We have to talk about the max of F is when F prime, let's try to make it easy on ourselves. When F prime changes sign from positive to negative, I'd write that down for a test, or an endpoint. Being this specific eliminates relative mins. Mins are not going to be absolute maxes. So F prime equals 0, a little bit of a waste of our time. Let's see if it's going to be easier than that, actually. It is easier than that because I see that my derivative from -4 to 6 is positive until 1, and it's negative from 1 to 6. So actually, rewind, erase, I have the answer. It's got to be at 1. F prime is positive. That means F is increasing, then decreasing. F prime is positive. G is positive. That means F is increasing, then decreasing. This must be the location of the max. Now, here's my justification. Max at, let's find the value, F of 1. F of 1 is the integral from 0 to 1, which is 2. Because F prime is positive from -4 to 1, and then F prime is negative from 1 to 6. And it's like 2, how is that the max value? How's the max value? And again, they're asking for the max value. The max value would be 2. How can the max value just be 2? Well, let's look at the areas. I start at -4. I found F of -4 already. F of -4 was -16. I then add an area of 18. Let's see. 6, 10, 16, 17, 18. I'm adding the accumulation from -4 to 1 of F prime is 18. I add 18 to get to 2. And then I decrease. I already found F of 6. What is F of 6? F of 6 is -8. I go from 2 to -8. That means my accumulation, my area from 1 to 6 under my derivative has to be -10. And let's check. Yeah, it was -10. It's just like, it all makes sense. It all makes sense. So like accumulations of a derivative, changes in total, boom. That's it. Let's just roll from here, start answering all my questions. Be able to adjust and adapt. All of a sudden, I have the graph of F. Okay, what is the graph of F? Well, the derivative of G is F. Again, ignore the T. What about that -3? Nothing. It just gives you an initial value. It just gives you a point. And when you take the derivative of that, it's like you take the derivative of the initial, it goes away. Okay, this graph of F is the graph of G prime. I'm purposely flipping up variables for you so you don't get stuck with like do this, do this, do this, okay? This is the graph of G prime. We can find some endpoints, which will help us later potentially. -3 to 4 of F. Let's go ahead and find some areas. I'm starting at -3. This is a base of 1, 2, 3, height of 1, 2, 3, 4. So 1/2, 3, 4 is going to be 6. Stopping there. This is a base of 2, height of 1, 2, 3, 4. So that's a 1/2, 2, 4, which is 4. This is a base of 2, height of -4. That's going to be -4. This is a base of 2, height of 2. That's going to be 2. Again, above the x-axis, I'm saying is positive. Below the x-axis is negative. I'm thinking about an accumulation from left to right. And then if I go backwards with my accumulations, I know I have to subtract. So it's like the opposite. So good. So -3 to 4, I have 6 because these 4's cancel. -3 to -5 of F. -3 to -5. Opposite. Subtract. I'm going backwards. I have to increase 2 to get to 0. Like G of -3 is 0. It's a good point to know. G prime will equal F. G prime now is F. Like I flip-flop the variables just to keep you on your toes. G prime equals F. G prime equals F. G prime of -1 is F of -1. I want the Y of F at -1. Oh, what's that value? Try to get you here. This is tricky. I'm going over 1, 2, 3, up 1, 2, 3, 4. Okay, so immediately I can see that slope is 3/4. That's up, 4/3, sorry. Up 4 over 3. Up 4 over 3. Understand that turning that into a rate of change, you could say 4/3 over 1. Now, why am I doing this? Because I have this point here at 4. If I go over 1, you might think that we're going to be at 3, but that's not true. 1, 2, 3, 1, 2, 3, 4. It's not a 1-to-1 slope. Instead, if you go over 1, you'll have to go down 4/3. So I need like 6 minus 4/3. So that's going to be like 5 2/3. 18/3 minus 4/3 is 14/3. This is probably the one question many of you are going to be like, what? What just happened? You have to be careful. You might have to apply a slope. Up 4/3 over 1, so I'm at 4/3. Up 4/3 over 1, I'm at 8/3. What is going on? 0. Up 4/3 over 1. I'm at, 4/3. Up 4/3 over 1. Why did I say I was at 6? I was not at 6, I'm at 4. This is why we check stuff. 8/3. Okay, up 4/3 over 1, I'm at 4/3. Up 4/3 over 1, I'm at 8/3. Tricky. Down 4/3 over 1, I'm at 8/3, coming from 12/3. G double prime, therefore, is F prime. G double prime is F prime. I'm looking for the slope of F. This is the graph of F. The slope of F at -1, up 4 over 3. We found that. That's tricky. Yo, heads up. Good trickiness, like finding a value that's not at a whole number. Oh, cool. We're not asking about concavity at all. We're just asking about G decreasing. So we can do all of our work here on one guy. Okay, like let's just do a full sign analysis. G prime will tell me about G going up or down. G prime's equal to F. I'm starting at -5. I'm going to 4. I have positive values until 2, and then I have negative values. G is going to be increasing, then decreasing. You can look at the areas under G prime, which is the areas under F. to realize you are increasing a total of 12, and then you're decreasing a total of 4. You already know what g of negative 5 is. You found it. It was negative 2. G of 2, let's just make sure from negative 3 to 2 is 10. Does that make sense? Negative 2 plus 12 is 10. Good. And then g of 4 is 10 minus 4. We already found it. It's kind of confirmed here. That's 6. Everything fits. Here is what we need to answer when is g decreasing. The x interval from 2 to 4. These are x's again. We're back to xy's instead of t's and p's. What is the max? Now here is another key. Don't look at all of your candidates. If you say g prime equals 0 or endpoints, that's a candidate right there. You know that's not going to be the max because you're going to be increasing and then increasing more. So don't say g prime equals 0. You can either say g prime changes sign from positive to negative or an endpoint, or if you know that there is one candidate, that's your max right there. G has a max at g of 2, which equals, I did not show the work, so I need to, negative 3 to 2 of f, which equals 10. Why? Because g prime, as long as the connection is established somewhere, we're fine. If you want to repeat it, great. G prime is positive from negative 5 to 2. And then g prime, which equals f, is negative from 2 to 4. I actually don't know if that's going to work because we do have a 0 here. We probably should say is greater than or equal to 0, just to be sure. Yo, you're not comfortable with that? G has a max when g prime changes sign from positive to negative. That excludes the non-maxes and mins, so that excludes this point or an endpoint. And then you just list off your candidates. G of negative 5, you had to show your work. Somewhere I showed my work as negative 2. G of 2, show your work. 10, g of 4, show your work. I showed my work earlier, 6. Okay, negative 2 plus 12, 10, minus 4, 6. Your numbers should work out. I change it up again. This is the graph of Q. This is the graph of Q. P equals the accumulation of area of Q. Well, that means P prime equals Q. Q is actually the graph of a derivative of P. Great. Established. Needs to be written. That's P prime. Sweet. Let's find some values. Negative 2 to negative 4. Heads up. You're going from right to left. This area, base 2, height negative 4 is negative 4. Take the opposite of it. That's positive 4. If you want to write down, it's the opposite from negative 4 to negative 2, or you're subtracting. Let's go all the way to 12. I start at negative 2. These are all the same triangles. So let's see. Base 4, height 4. So 1/2 base 4, height 4 is 8. So that's an 8, that's an 8, that's a negative 8, and that's going to be a negative 4. All right, cool. So accumulate from negative 2 to 12 Q, and you get 4. All right, cool. I start at 4. I decrease 4, I got 0. I increase 8, I got 8. I increase 8, I got 16. But I subtract 8, I get 8. I subtract 4, I get 4. Okay, works out. All right, P prime will equal Q. You got to have it written down. Don't just do this all the time. This is the Y value of Q. At negative 2 is 0. P double prime, therefore, would equal Q prime. So Q prime is the slope of Q at negative 2. I'm going up 4 over 2. So up 4 over 2 is 2. All right, points of inflection with justification. When P has a point of inflection, P double prime will change signs, or P prime will change directions. That causes P and its concavity to change. Okay, now again, what are we looking at? A graph of Q. Q's direction changes, or Q's slopes values change. Okay, I'm going to say P has a point of inflection when P prime, which equals Q, changes direction. From increasing to decreasing or decreasing to increasing. I'm pretty sure they'd accept that. I don't know. We change direction at 0, 2, 4, 8, and 10. That's a lot. What is the min value of P? Let's just like get ready. So I'm not going to do all the work. Let's just see. Okay. I have one relative min. My relative min is at -2. I increase 4. No, I decrease 4 to get to that relative min. Then I increase 16, decrease 8, decrease 4. Yeah, that's going to be the winner. But it's not clear because we have multiple sign changes. Because we have this 0 and that 0, our endpoints could be in play. I can kind of figure out by looking at like, oh, I'm going to be increasing more than I decrease. This is going to be the winner. Instead, if you're not sure, you can always go to a min of P when P prime changes sign from negative to positive. That eliminates you having to check all candidates or an endpoint. So if you want to have it down, great. You don't. Really, you have your value at -4, which we found was 4. Our derivative is negative until -2. We should find P of -2. Now, P of -2 is just going to be 0. I have to show my work for that, though. Then I see positives until 6. Now its positives are equal to 0 until 6. And then negatives are equal to 0 until 12. My area under P prime from -4 to -2 was -4. Okay, I went from 4, I subtract 4, I get to 0. To get to 6, I'm going to increase 16. That makes sense, like plus 8 plus 8. So P of 6 is going to be 16. And then let's get back down to what we expect. P of 12 is supposed to be 4. Okay, subtract 8, subtract 4. That's subtracting 12. Yep, it works out. This gets us 4. 4 minus 4 is 0, plus 16 is 16, minus 12 is 4. Now, you need to write off your candidates. Your candidates where P prime changes sign or an endpoint. If you want to go ahead and specify it, here's your endpoint. You found it earlier. You showed your work earlier, so you don't have to do it again. But you did not find P of -2, so you need to show your integral and its value, and then state that's the winner. Min by your candidates test. Oh, half circles are in play. Oh, they're changing it up again. This is the graph of M. Okay, that's the graph of M. This is the graph of M. Oh, N equals the accumulation of M. Well, because integrals, accumulations, antiderivatives go hand in hand, N prime is just going to be M. So this is actually the graph of the derivative of N. If you want to do a sign analysis, you can. But you know, M of 4 is 0. Like, this is another approach to doing these problems. Go straight to your sign analysis. M, which equals N prime. This is the derivative. This is n's value at 4 is 0. I know that's 0 because you got that. Let's find some areas. 1, 2, 1, 2. So this is 2. This is a 1.5. That's a rectangle and a half. So if I wanted to go all the way to 7, I'm going to add the accumulation of my area from 4 to 7, which is 3.5. N of 7 should be 3.5. Showing your work, though, would require you plug in 7 for x. The accumulation from 4 to 7 is 2, 3.5. Yeah, that makes sense. I start at 0. I add 3.5. Boom. My derivative was positive. These values of my derivative are positive, which means n is increasing. All works. It all makes sense. It's all something we've done. Now, what if I go back in time to n of 0? Okay, this is a semicircle whose area is a half of pi r squared. R is 2, so this is a half of 4 pi. This is going to be negative 2 pi. Now, here's the kicker. That area from left to right is negative 2 pi. If I were to go backwards, it would give me minus a negative 2 pi or plus 2 pi at 0. If I were to find this accumulation from 4 to 0, I'm going backwards. It's the opposite of the accumulation from 0 to 4. So that's positive 2 pi. Now let's make sure this makes sense. I start at 2 pi. I then have this accumulation of minus 2 pi. I get to 0. Good. 4 to 4 is 0. No chance to accumulate. Then I add 3.5. I get 3.5. We're good. Everything makes sense. Yo, absolute min. And then this is actually going to be the absolute max because 2 times pi is going to be more than 3.5. You could do this if you want to. Okay, n prime equals m. It's always good to not always do the same thing, but to double check. Next lesson, it's going to be a little bit more difficult. M of 2. Ooh, M of 2. M of 2 is that y coordinate on that semicircle. Well, there's no way to use a slope here. It's just kind of knowing that that's the minimum of my semicircle, and that's going to be like that radius. So this, again, is the y of m. M prime equals n double prime. N double prime equals m prime, which is the slope of m. Okay, that's confusing. What's the slope there? It looks like it's a horizontal tangent, and you'd be correct if it was. When is n increasing? When n prime is positive, that's from 4 to 7. What is the min value of n? I keep giving you these ones where they're not at endpoints. Why did I do that? This is a min. All right, that's a good one. I'm changing this up to a max. The min's going to be n of 4, which is equal to 0, and you don't need And now, what is the min value? They're asking really for the y value. So just provide your x and your y value. I'm going to do both the min and the max. That's the min. Why? Because n prime, which equals m, is negative from 0 to 4. And then n prime, which equals m, is positive from 4 to 7. Again, these are x values. These are the x values that I'm talking about. The y values are like the results that we get. You don't say from 2 pi to 0 and from 0 to 3.5. Don't say that. I'm sure some of you are going to do. Now, max. You could say a max is when n prime changes sign from positive to negative. I'd write that out for the test. Or an endpoint. This eliminates 4 from being a candidate for the max because it doesn't change sign from positive to negative. It changes from negative to positive, which means you only have to check your endpoints. You check n of 0, 2 pi. You check n of 7, 3.5. You've showed your work for that. Make sure you show your work for that using integrals. If you don't show your work for that, I'm not giving you credit. What is it? 4 to 0. This is positive 4 to 0. And this is positive 4 to 7. If you don't show your work for that, you don't get any credit. This is the max. It's one of the endpoints. All right, 2 more. All right, we're in good shape. Okay, this is the graph of f again. Okay, this is the graph of f. G equals the accumulation of area under f. T dt, don't worry about it. It's like it just is a necessary evil, but it causes confusion. What's the key? G prime equals f. This is the graph of a derivative. This is a rate of change of f. This is the rate of change of G. It's a rate of change of big F. Anyways. You want to start with your sign analysis everywhere? Let's do it. Sure. G prime is telling me about G. We got an endpoint at -4. We got an endpoint at 3. I have a 0 at -1. That's nice to have. How do I know that it's 0? I probably have to show my work if I use that value. Let's look at some areas. I'll split this up. Split this up. Base 2 height of 1. Base 2 height 2. Base 1 height 3. That sucks. No. Radius 1, half of a circle. This stinks as well. But get used to it. 1/2 pi r squared. Negative pi over 2. Base 2, height -1, -1. Okay. Let's look at some areas. From -4 to 0, the area under my derivative, the area under f, is 4, 5.5. That means if I go back in time, if I want to go from -1 to -4, I'm going to have to subtract the 5.5. Okay, so I got a -5.5. I add 5.5 to get to a 0 right there. Bam. Might as well put in 1. It's going to be negative pi over 2. Oh, nice. Got to show you work. From -1 to 1 of f, I have negative pi over 2. That's the area. And then from 1 to 3, I subtract 1, which means g of 3 is going to be, stay with me, negative pi over 2 minus 1. It'd be nice if it was whole numbers, but it's okay. Making sure everything works out. I start at -5.5. I add 0.5. I get to 0. I subtract -0.5. I get to -0.5. I subtract 1. I get pi over 2 minus 1. I'm adding all of these values, or like adding -1. All right, g prime of 2 is equal to f of 2. And again, this is positive, negative, negative. That tells me g is increasing, decreasing, decreasing. That's my overall max. I don't know. Overall min, -5.5 or negative pi over 2 minus 1. It's going to be -5.5. Negative pi over 2 is like 3/2 minus 1. 3/2 is 1.5 minus 1 is minus 2.5. So minus 5.5 is going to be my overall min. Thanks. F of 2 is the y value of f at 2. Ooh, I go down 1 over 2. Yeah, I'm trying to get you here. Slope is down 1 over 2, which is down 1/2 over 1, making it a rate of change. Down 1/2 over 1 If I go to the y-coordinate of 2, I'm at y-coordinate when x is 2, I'm at a y-coordinate of negative half. G double prime equals f prime is the slope of f. I found the slope is actually the same, down 1 over 2. This, though, is the y of f. This is the m of f. When does G have a point of inflection? Okay, again, G double prime, which equals G prime, will tell me about the G double prime, which tells me about G prime, will tell me about G. G double prime switching signs means G prime switches directions, which means G switches concavity. G prime changing from increasing or decreasing and vice versa. G prime equals F. G double prime equals F prime. So we're looking for when F changes direction. -2, 0, and 1. Increasing, decreasing, decreasing, increasing, decreasing. Min value. G has a min. Let's do a little bit of like carefulness. If you want to say when G prime equals 0 or an endpoint, great. You just have 3 candidates that you'd have to write down. You've already found all your candidates, so you just write them down with the work and you're fine. If you want to not have to check all your candidates, you know that this 0 and this 0 are not candidates for mins because that's a max and we know we decrease after that. We adjust our statement. So this is more understanding where candidates come from and making sure we just don't blindly do the same thing, which might cause a lot of work. We just understand G is a min when G prime changes sign from negative to a positive, which means it's a relative min, or an endpoint, we'd have a min. There's no time when G prime changes sign from negative to positive. So all you have to do is check your endpoints. G of -4, which we already found, but let's just like make sure we show the work for it. -5.5. And then G of 3. Make sure you show the work for it. I haven't shown the work for it yet. -pi/2 minus 1. You got to compare the values, and that's the winner. Candidates. This is where my candidates come from. These are my candidates. There's only 2 of them. Boom, that's my candidates. All right, last one. This is the graph of G. Okay, this is the graph of G. What's special about the graph of G? G is actually the graph of the derivative of f. Just like take the derivative, make sure you makes sense to you. Yo, this is complicated. Let's do the sign analysis first. F prime is going to tell me about f. We got f of -2. We got f of 5. I have a 0 at 0 because that's where I start. Okay. Why did I do this to you? Because I can. This is a slope of up 2 over 1. Up 2 over 1 is equivalent to, divide the top and bottom by 2, up 1 over a half. This point is a half. This teeny tiny little triangle right there is a triangle base 1/2. So 1/2, base 1/2, height -1. And that's -1/4. Great. This triangle here is base 3/2, height 3. What am I doing here? 9/4. Ha! This triangle right here is a half. It's negative a half. Why didn't I start it at -1? I don't think it would have made that much of a difference. This triangle here is positive a half. Fun. And then, what the heck is this area? Now that's important. It's not this, guys. It's not that inside there. No, we accumulate, we add up the G values. These are G values. We got to add them up. It's this area right here. This would be the accumulation. How are we going to find this? Well, wow. This is a quarter of a circle, radius 3. So this is a 1/4 pi times 3 squared. This is 9/4 pi. That's this area here. How do I find this area here? Well, this is a rectangle, 1, 2, 3, 1, 2, 3. This is a square with an area of 9, which means you can take the area of 9 and subtract the 9/4 pi, and you get that. Great. Yo, it might actually be best not to find some function values here. Rather, do the following. Know that f of a half is going to be a relative min because f prime is negative. F prime is also negative through 0. I really threw it at you here. It's positive from -1 to 2. It's positive from a half all the way to 5. Okay. We can look at our accumulations if we wanted to. Let's look at our accumulations of f prime, which are the accumulations of g. We have plus a half. That's easy. Then we have minus a half. That's easy. Okay, well, that means this has to be positive a half, and this has to be 0 again. 0 plus a half minus a half. Yeah, that's good. Then I'm going to decrease by a fourth. This is minus a fourth. Then I'm going to increase a boatload. 9/4 plus 9 minus 9/4 pi. Now, like, yo, it's free response. Leave it. If you want to change this to 36/4, adding 9/4, 45/4, great. I don't want to do that. Wait. Hold the phone. Damn. I just caught myself. I'm going to increase, silly Mr. Messner, 9/4 plus 9 minus 9/4 pi. Off of negative a fourth. So that actually turns into 2 plus 9, which is 11. Yo, that's actually easier. 11 minus 9/4 pi. Even still, I don't love it. Okay, because I start at negative a fourth. Plus 9/4 is 8/4, which is 2. Plus 9 is 11 minus 9/4. It should make sense. Like f is increasing until that. Here's the amount. F is decreasing. Here's the amount. F is decreasing. Here's the amount. F is increasing. What's the max value? Well, there's actually 2 candidates. I don't have to check this, but like whatever, it's going to be easy. Max of f is when f prime, which equals g, changes sign from positive to negative. You'll write that out on your test, or an endpoint. I can exclude this endpoint, but whatever, you already found it. F of -2 is an endpoint, which is the accumulation from 0 to -2, which I didn't show, of g, which is 0. Already found that. Where do we change signs from positive to a negative is f at negative a half, f at -1. Which is accumulating g from 0 to -1, which is the opposite of -1 to 0, which is why this is a positive, a half. So important, guys. Go left to right. Everything should make sense. 0 plus a half, minus a half, 0, minus a 4. Boom. 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 Okay. And then the other endpoint, because there's no other time when we change signs from positives to negatives, is f of 5, which unfortunately is this number. What's bigger, a half or 11 minus 9/4 pi? I'm thinking about this, actually. Pi divided by 4 is like 3/4. 3/4 of 9 is less than 9. 11 minus something less than 9 is going to be something bigger than a half. That's your winner. Kind of visually see. Here's my 0. I'm just going to decrease. I'm just going to increase. Wait, we're talking about max. Here's my 0. I'm going to increase just by a half. Decrease a little bit. Like, this should make sense. Increase a half. Decrease a half. Decrease a fourth. Okay, so I'm only a fourth off of kind of where I started, and I'm only like 3/4 off of my relative max. And then I add all of this accumulation, all of that area, and you can visually see it's more than how much we decreased or how much we increased. So it's gonna like pop us over the amount that we decreased from our max, which is only 3/4. We decreased 3/4. We're already back to where we started when we get to an area of 3/4, and then we have all this extra. So that makes sense, hopefully. This was your challenging one here. If you got this one, great. If you're copying this down, well, then nothing really helps you. We already found this. We already found this. We'll find this. We'll find this. Oh, I changed it up on you. Up 1, 2 over 1. Guys, I hope you see it's all the same stuff. This unit's really all the same stuff as last unit. We do have one more lesson that makes it a little bit different and a little bit fun and complicated. And you'll have to not just do this. You have to really adjust and adapt and be a math student that is not a just do this math student. So we'll see that next class. Later.